Bismillahirrahmanirrahim. Assalamualaikum. Okay, in this video, we will discuss about the looping and looping analysis. Okay, as we know, program not run just in a single line mode, but sometimes it needs to go through or to execute a certain looping like this one. Okay, so for looping, it is it will run more than one time. In this case, it will execute this two instruction more than one time, maybe 10, 20, 100. It depends on how we setting the coding. Okay. Now we will learn how to analysis the looping. Okay, like this one. In this flowchart, I ask my copy to copy a value 100 to R1, follow subtract R1, check R1 condition either 0 or not, and then proceed to the next and next instruction. So in this case, for this conditional instruction, it will loops more than one times. So let's let's analysis this looping. First, R1. For R1, I copy value 100, and then I subtract R1 with 1, and then I check the condition. So in this case, for all of this instruction, it will execute minimum one time. Okay, minimum one time. If let's say the value for R here is 1, R minus 1 is 0, and then R is equal to 0, yes condition. Yeah. So I use this block to indicate that all this instruction 1, 2, 3, 4, 5 will execute at least one time. Second, for this looping, I use another block, the green block, to indicate that it is represent this looping, the green looping. So R1 100 minus 1, check until 0, meaning that 1 minus 100 until 0, this looping will loop for 100 times. So we can say that this program will start here, will flow here, and then will loop inside this looping for 100 times, and then it will exit this looping to continue execute next program. Okay, so here for this green looping, I put it at 100 times. So we can say that these three instructions will execute for 100 times. So the total looping will be 100 times 3. It will take 300 cycles for the microprocessor to complete this looping. So total clock cycle in this portion of program will be 300 plus 1 plus 2 plus 3 plus 4. 304 uh, 304 cycles. Okay. Okay. Next is loop inside a loop. Here you can see here, using this original program, I add another looping outside this looping. So we can see that this green looping was actually placed inside this red looping. So for red looping is depend on R2, because R2 will determine whether program will still execute this looping or not. And for green looping, is depend on R0. In this case, the initial value for R1. Initial value for R1 is 100, so that the green looping will execute for 100 times, 100 loops. And for red looping, the value is depend on R2. So in this case, I put R2, let's say 50, to differentiate between the R2 and R1. So a red looping is depend on R2. After uh, after I put R2 here, I put a value for R1, and then value for R1 will be decrease one by one until it reach 0, and then it will reduce R2 by 1, and then check R2, and for looping R2 it will reset back the value for R1 into 100, and then the value will be decreased again and again. Okay, so we can say that after every 100 times the green looping is happen, and then blue looping will be execute once, and then it will reset back R1, and then again green looping will be loop for 100 times. Okay, so to analysis this looping, this one is similar with the previous program. The green one will loop for 100 times, and the red looping here, the red looping will execute for 50 times, because I use the value 50 for R2, and then we check R2 here. So that's why I call it as a looping inside a loop. Okay. So to analysis the number of clock cycle, I use like this. I use a green bar to indicate the number of green looping, and the red bar for the number of red looping. Red bar for 50 times, and green bar for 100 times, and the blue bar is for all the other program, meaning that all the other program will execute at least for one time. Okay, so to calculate the number of clock cycle here, 1 times 1, 1 times 50, because this instruction R1 will move R1 by 50, uh, will be executed for 50 times. Okay, 50 times until from 50 to 0, until it reaches 0. So meaning that this instruction will be executed for 50 times. Same goes to this one. But for this one, it will execute 50, 50 times 100. 50 times inside a red looping, and 100 inside a green looping. So here 1 times 50 times 100. So this instruction R1 minus 1 will be executed for 5,000 times overall. Same happen to this compare and BNE, and also SUBS. Sorry, SUBS is only 50 times. Similar with the here MOVS R150. Okay, so to sum to sum up all this number of clock cycle, we just add this number 1, 50, 5,000, 10,000. This one is 10,000 because 2 times 50 times 100, because for this process it got two instruction, compare and branch. So all these two instruction will execute 50 times 100 times. Okay, so the total number is for clock cycle is 50,202 times, because this one will execute for one time. Okay. Okay, if we want to know the actual time, how much time is taken by this program to complete, we need to know the time for one clock cycle. Okay, based on the based on the clock frequency, we can calculate the time for one clock cycle, and the value of time we can multiply with this number of clock cycle. Okay, and then we can get a real value, real time value. Okay guys.